How does an F1 combustion chamber create power? Imagine a tiny space where fuel and air come together to produce a burst of energy that powers a race car. That's what the combustion chamber in an F1 engine is all about. It's the heart of the power unit, where fuel gets turned into motion. Inside this chamber, fuel and air are carefully mixed and then compressed by the piston moving upward. When the piston reaches the top of its stroke, a spark plug ignites this mixture, causing a small explosion. This explosion creates a huge amount of pressure and heat, forcing the piston down with incredible force. That movement is what ultimately turns the wheels. F1 combustion chambers are built to withstand extreme conditions. They operate at very high pressures and temperatures, much more intense than regular car engines. The chambers are designed with precise shapes to make sure the fuel burns as completely and quickly as possible. This efficient burn produces the maximum amount of force from each explosion. The shape and size of the chamber are carefully engineered to optimize this process, ensuring the engine produces as much power as possible while staying reliable. The engine in an F1 car is a 1.6-liter turbocharged V6 with 6 cylinders, each with its own combustion chamber. These chambers fire thousands of times every minute, helping the engine reach around 15,000 revolutions per minute. This rapid firing produces roughly 840 horsepower from the internal combustion process alone. Fuel flow is tightly controlled, with a maximum of 100 kilograms per hour, so the engine reaches its peak power around 10,500 revolutions per minute, even though it can go higher. When the fuel ignites, the force pushes the piston down, connected to a rod that turns the crankshaft. This converts the piston's linear movement into rotational energy, which then powers the wheels through the transmission. Turbocharging plays a big role here, as it forces more air into the chamber than normal. More air means more oxygen, which allows for more fuel to burn and produces more power. The turbocharger spins at up to 150,000 revolutions per minute, compressing incoming air before it enters the chamber. The combustion process is also boosted by the motor generator unit heat, which captures energy from exhaust gases. Instead of wasting this energy, it spins the turbocharger when the driver is off the throttle, maintaining boost pressure and improving efficiency. The entire system works together with electric motors, like the motor generator unit kinetic, which adds extra horsepower during acceleration. This hybrid setup can produce up to 1,000 horsepower in total, combining the combustion power with electric energy. Looking ahead, F1 is planning changes for 2026. The combustion chambers will produce less power, around 540 horsepower, but the electric motors will take on a bigger role. The motor generator unit kinetic will increase to 470 horsepower, and the motor generator unit heat will be phased out. This shift aims to make the cars more electric-focused while still relying on the combustion chambers to generate power. So, the combustion chamber is where the magic begins. It transforms fuel into explosive energy through a carefully controlled process that involves compression, ignition, and expansion. Every detail, from shape to timing, is designed to squeeze out the most power possible, making it the core of what drives an F1 car forward.